Hi, my name is Brianna Vargas Coya, and this is my Interactive Advanced Concepts Presentation 6 for Biochemistry 1. Thank you. To start off, I wanted to go along with the background information. Aspirin was one of the first drugs to ever be produced in the late 1890s. Aspirin was discovered by Felix Hoffmann at Bayer in Germany. It wasn't until much later that we discovered the mechanism by which aspirin works, and today there's a huge wealth of information available about how exactly aspirin works, including its inhibitors, COX. And ultimately, I'm going to be investigating throughout this presentation how aspirin works, investigating that on a pathway level as well as a mechanism level. Continuing on with aspirin, aspirin causes several different effects in the body, mainly the reduction of inflammation, as it also relieves pain, the prevention of clotting, and the reduction of fever. Working in the public health and medical field, you always see Bayer aspirin is being prescribed for, preventing a lot of heart conditions and aiding in heart disease and other similar heart illnesses. Continuing on, much of this is believed to be due to decreased production of the prostaglandins and TXA2. Aspirin's ability to suppress the production of these is due to being reversible inactivation and of the COX enzyme that was mentioned earlier on. And with this causes aspirin to act as an agent where an acetyl group is covalently attached to another coenzyme, and this makes it different than other similar types of medication like ibuprofen and Tylenol that try to do the same, suppressing illnesses and pains and aches in the human body. Ultimately, aspirin has been shown to have 3 additional modes of action. As mentioned with the COX pathway, it uncouples oxidative phosphorylation in the mitochondria and diffuses it through the intramembrane space as a proton carrier back into the mitochondrial matrix, where it ionizes once again to release protons in short aspirin buffers and transports the protons, acting as a competitor to ATP synthesis. When high doses of aspirin are given, aspirin may actually cause hypothermia. Therefore, as I mentioned, it can be used in a positive and negative light in medicine. It needs to be taken properly, and the doses need to be adjusted accordingly to the patient in order to reduce heart disease, heart attack, or even more seriously, death. So when further doing research on aspirin, I thought it was important. This was one of the first images I saw when you literally just search up aspirin on Google. And it's important to know that it is a blood thinner and a non-sterile anti-inflammatory drug that can treat pain, fever, headaches, and inflammation, as I mentioned before, and with the reduction in risk of heart attack. And it's very important to consult a doctor just because of how much of an impact this medication can have on not only the human body, homeostasis, and the entire way of living and being for a human, but it also does impact other medications. And with that, prescriptions are most often needed, or cardiovascular and other cardiologists will have to monitor a patient. As I mentioned, I did more further research on Google, and I thought this was very important just to understand how many different types and variants of aspirin there are in the market, and how much regulation does still need to be approved for aspirin just because of how high the dose is and its impact, its effects, side effects on patients. And with that, I just wanted to show how many variants there are, even when you just search it up on Google Images, and how each different strain of aspirin impacts other areas, not only just the heart, other organs, other body aches, muscles, and therefore aspirin is very important part of not only medicine, but it's very common. You go to Walgreens or any other pharmacies, you would always find aspirin, or very common, Bayer. And I think it's very important because to understand more of like the background and pathways on how it actually inhibits, it does reduce the swelling because it attacks similarly. I would say through my research, it does similarly attack almost like a radiation or chemotherapy, but not to that extent of causing excessive harm on attacking the cells, whereas Bayer and aspirin are attacking slightly elevated cells or slightly muscles that are in pain, ache, and it attacks it actively to reduce any more spread or any more other issues that could occur. And I think that that's a great comparison. As I mentioned, though, it's not to an extent causing a lot of toxins in the body because it is regulated more thoroughly, and chemotherapies and radiation vary, the dosage and all the other components to that vary based on the patients. Overall, this is my presentation on aspirin, and I wanted to do more of a modern take on it, especially how the background information on our prompt discussed how important and how relevant it is in the market, and I wanted to combine that with the modern perspectives and just how relevant it is to our community and society and the world all over.